Hi, good morning everybody. I am engineer Bala from India. I work and live in Vietnam. This is my technical blog. I used to do a lot of blogging in Tamil. I wanted to do something related to my profession for the young engineers. Thanks for watching. Bangalore begins. Engineers encounters. Number 1. In 1980s, engineering education was a rare commodity. Just 8 engineering colleges were present in Tamil Nadu, India then. Competition was fierce, and getting admission into an engineering college those days was a blessing. I was lucky enough to secure a seat in PSG College of Technology in Coimbatore, called shortly as Tech by its alumni spread across the globe from Canada, America until New Zealand, covering the entire globe, the entire surface of the globe. Having completed my bachelor's degree in civil engineering, I worked for a year to repay my educational loans and continued my master's in structural engineering in my parent institution. I had the opportunity to serve as a lecturer in my college, but I could not get a permanent posting due to my carelessness in not renewing my number with the government employment exchange. My life after that, in a way, similar to the famous Tamil movie 12B, had taken a turn. Had I got the employment exchange number, I would have completed my doctorate in my college and might have served 30 plus years there by this time for sure. Having missed the bus called the employment exchange number, I landed up in a different profession. I landed into the steel bending industry as a structural design engineer. It was a famous company in Bangalore. They gave me interview papers for 3 full hours, followed by the interview for the whole long day. Later, I understood more than the engineering knowledge, they test the endurance of the individual and his patience to sit and work for long hours, days and nights, and weekends to follow. In those days, out of 10 civil engineers, I'm talking about in 1990s, in those days out of 10 civil engineers, 1 landed in the design office while the rest got the assignment at site. Out of those 10 designers, again 1 landed into steel design, and I was the lucky one, I would say. When compared to that, now in 2020s, we have plenty of steel designers, detailers and modelers in the industry, thanks to many engineering institutions available now and the revolution in information technology and the latest computer-aided design methods available currently in the market. When I happened to work in the most prestigious institute in Chennai as a project associate after my graduation, we had no desktop computers. Coding for structural analysis was to be punched in cards and fed into huge, gigantic machines. After a laborious process, we can get out the paper printouts and check the results for equilibrium of forces and reactions. When compared to that, nowadays the coding is simple. You can use text and you can use the graphic user interface, and life has changed a lot. Like using the text-based mobile phones to smartphones now. What a huge transformation. Later in Bangalore, in 1990, our company had a shared desktop PC with a small program loaded in it for structural analysis. The program was called as a microstress, and it served our basic requirements for structural design. The drawings, however, were still not computer generated. They were handmade by a bunch of senior draftsmen working on the drafting board using the transparent A1 size papers and the pencils and black ink pens. Lot of scratching involved. The corrections and doing the modifications were really nightmare for them. Once they finished the drawings, we need to go to the lower floor. There was a ammonia printing machine. In that, the blueprint was taken, and I can still feel the fresh smell of ammonia while we were waiting to collect the drawings from our people there. And then we had to fold them in a methodical way and go for submission to the architects and to the customers and all. The steel design was undergoing a revolutionary change by that time. The built-up sections for main steel were yet to come. Still, we were using hot-rolled I sections and pipes for steel columns, and we used steel angles for the truss arrangement. It was the purlin that underwent the first change. From the hot-rolled C sections, we started migrating to the cold-formed Z sections. Nagarjuna, I think it was called NSL then, and Murugappa, the Timset purlin. I think they were the pioneers who made the Z sections or the Z sections those days, if I remember correctly. I think now we may be having more than hundreds of manufacturers in India who make the cold form sections and the sheeting and all. Our project, the first one with the Z sections, was commissioned successfully in Mysore. That was really great to see that one those days. When it comes to considering the steel building as a child or similar to a human being, here is my understanding, friends. The building is conceived by the design team, say we can call them as the father of the child. The factory which fabricates the building can be called as a mother who carries it for 4 to 8 weeks, if not 10 months like a human baby. And when we talk about the delivery of the child, the steel building, actually it takes place at site. And whether the delivery is a normal delivery or it is a cesarean or a C-section delivery, it depends on the erectors who we choose. I think the right erector is the most essential component in a steel building construction. End of the day, what you have conceived and what you have fabricated, it is the erector who erects and make the building stand and function the way it has been designed. Our company had supplied a steel building before I joined them. Later I came to know that building, while it was being erected, it fell down and one or two workers, poor fellows, they got crushed under a steel truss which collapsed at the time of erection. Later, the root cause analysis was made to find what was the reason for the disaster. The configuration was north-light trusses sitting on the lattice girder, which in turn sits on the steel columns. It was the erection sequence which created the problem. Until erected in position properly, trusses need to be supported on cranes. Starting from one end wall to the other end, we need to proceed. They had to start from the right end wall and erect one lattice girder and erect the north light trusses and make the system stable and keep proceeding on the way. Unfortunately, they chose the wrong end. They came from the other end wall, wherein they had to simultaneously hold two lattice girders and keep erecting the north light truss in between. That was told as the reason for the collapse at that time. Anyway, you need to take a lot of care to do the proper erection. Even after 20-30 years of my remembrance, until now we see the buildings falling and collapsing at the time of erection, the buildings and bridges. Mainly the reason, when they erect the main frames, they need to erect the roof and wall bracings simultaneously and then lock it bay by bay, and they need to proceed. If they erect the frames and they remove the guy wires and without properly erecting the bracing, if they go for the other arrangement, then it always calls for caution. The main frames, the purlins and the bracings need to be erected to make the building stable. Having said this one, my friends, I am happy to conclude the engineers encounter number 1 with you. I will come with more such encounters in course of time, and thanks for watching, and please share your comments. I think I am seeing a lot of videos in YouTube regarding the pre-engineered buildings and about the structural steel buildings. Mostly these are made by the people who are related to marketing. I don't blame them. It's their job to market their product. At the same time, we have to ensure that we try to give reasonable and accurate information to the viewers to make it professional. Thanks for watching my video. See you in the next video. Bye bye until then.